Hi, welcome back to LeetCode. In this video, I'm going to discuss today's LeetCode bi-weekly challenge third problem. 3,332 maximum points tourist can earn. So, problem statement is that you are given two integers n and k, along with two 2D integers as stay score and travel score. So, a tourist is visiting a country with n cities, where each city is directly connected to every other city. The tourist journey consists of exactly k0 index days, and they can choose any city as their starting point. Each day, the tourist has two choices: stay in the current city, okay, and another is move to another city. So if he stay in the current city, then what is the score he can actually earn? They will earn stay score of particular day, ith day, and current city points, okay. And if you move to another city, then what is the score he will earn? They will earn travel score, current city to destination, or another city they are actually moving, okay. So return the maximum possible points the tourist can earn. So it will be actually easy. So if you take the example, then it will be easy too. So n is equal to 2. So there are two cities and k is equal to 1. Only one day you want to traveling. Now, what is the stay score? 2 and 3 means day 0, city 0, city 1. Correct? There are two cities possible and only one day possible, so that's why day 0 and city 1. Okay, this is for stay score. And if it is travel score, 0, 2, 1, 0. That means what? Current to destination. 0, 0, 0, 1, 1, 0, 1, 1. So what they are trying to say? So 0, 0 means they are not actually moving. 1, 1 means same. They are actually not moving. So that's why this is 0. 0, 1 means currently he was at city 0 and moving to city 1. What is the score he will earn? 2. And if he is at city 1 trying to move city 0, then he will earn point. What is the point? 1. Correct? Now they mention that he can start, visitor can start from any city. So he can start from city 0 or city 1 and day 0. What is the possible? What is the option for him? One is to stay here or move city 1. Only one city are possible. And for city 1, if you start from city 1, then stay in city 1 or move city 0. Okay. If you stay here in the city 0, what is the score he will earn? 2, or move to city 1, then what point you will earn? Again 2. Okay. Now if he stay in the city 1, what is the point he will earn? He will earn 3. And if he move to city 0, what is the score he will earn? He will earn 1. So out of all of this, what is the maximum value? 3. So that's our answer will be G3. Clear? It is clear. So what is the option for the visitor for any day? For any day I, his option 2. First option 1 is stay here. So what is the score he will earn? Stay score of particular day and particular city. Whatever the city actually here currently present. And option 2 is move to other city. So what is actually score he can actually earn? He will earn travel score from current city to destination, and plus whatever the value actually he will score he can actually future. Suppose this is x. Correct? And similarly for similar case, stay here and next day it will actually return from day day plus 1, like next day from next city. There is any again two possibility. So recursively you can actually solve this, correct? Recursion actually you can relate the problem, right? How actually recursion actually solve this. So I can start from any city I. Okay, I will have a day, like for which day actually you are coming, and we will actually have stay score or travel score in this way. Okay, now for option 1 is actually, I suppose this is actually one function, help function. So option 1 is, what is the value? I am staying here in the current city, so stay score in the current city I, plus again I am calling this helper function. I am passing the again city, same city I, and day plus 1. Here actually I have changed the next day, correct? Because I have already consumed one day. Next option 2 is what? Whatever the number of cities are present, available or possible. So I will go to each city. I will try to move that city, each city. So what is the score actually I will earn? I will earn travel score from this current city I to j, and plus helper function will return from the calculate the maximum score he can return from day plus 1. Or if we go to the city j, we are going, day will be changed day plus 1 because I have already consumed one day, correct? In this actually I will check what is the maximum value out of all of this, and that will be actually I will have to return, correct? Now go to the actually code. So first of all, this is a function max score. What will actually get? We will get n k number of cities and number of days, and the stay score and the travel score, correct? And we are actually dp I will actually come later. How actually recursively we are actually using memoization here to optimize this. Okay. Now we have to return an integer variable maximum score, that is initially answer is equal to 0, and I can start from any city. So that's why I'm starting 1 from 0 to n minus 1. Okay, like starting I am checking if I start from city 0, that what is the maximum score actually I can earn. Okay, then I am starting from 1 in this way. Okay, so I am calling this helper function where I am passing the current city, day 0, this is constant, n, k, stay score, travel score, dp I will actually come later. And ultimately after all of this city starting from this and reach at the day after consume the day k, what is the maximum answer actually got, I have to return that. Okay, so now come to this helper function, help. So if a city greater than equals to 1 n, or if we have reached the k, means number of days, so that time return 0 because we can only stay maximum day k. This is for dp purpose. Now what is the option 1? Option 1 is if we stay in the current city, then what is the score actually I can actually earn? Stay score, current day, and the city. Current day and the city. Actually currently I am we are here there, and I am calling the next day helper function again, passing the same city because we are staying here, and day will be changed to day plus 1, n, k, both all are remaining will be same. Next option is if we move to other cities. So there is multiple cities are possible, so that's why what I'm doing, I am taking p2, another variable, initially it is 0, and how many cities are possible? I0 0 to I less than n. There are n cities are possible. So if our I is equal to city, that means what? We are moving to the current city again. Means we are just staying here. So that's in continue because I have already checked it. That means if we I to I, that means what? We're actually staying in the current city. So that time the score will be stay score. I have already calculated that. Now, if we move that, so what will happen? So I will take the maximum value of P2 and the travel score of city I, city to I. City, currently we are in the city, and I am moving to city, next city is I. So that's why this will give us a travel score, and I'm calling the helper function again. What to do? I am passing I the next new city and day plus 1. Okay, and out of all I will check, we actually check all the possible cities I can actually get, and then take the maximum value I can actually get, maximum score, and ultimately I am storing in the current ultimately I am returning this maximum value out of these two options, stay here or move to other cities. I have to return this. It's clear. If any doubt, any suggestion, you'll comment on that. I'll definitely reply. Now, what is the this is for recursion. Now you can check, we actually recursively are actually calculating the same things multiple times. How? Suppose this is option city 0 1, okay, and suppose day 0 day 1, okay. So first of all, what will do, first of all option is stay here, day 0 also stay in the city 0, day 1 also stay in the city 0, city 0, yes. Now what is the option, go to the city 1 option, in the day 1 go to the city 1, day 1, day 0 you are in the sorry, day 1 day 0 you are in the city 0, but day 1 you go to the move to the city 1, okay. This is one possible. One possible is move, another possible is move is start day 0 is starting from city 1, day 0 you stay in the same city 1, and day 2 also stay in the same city 1, okay. Now in day 0 day 1 you actually move to city 0 again, correct. Now you go to the day 2. This is clear. What actually we can do, we can stay here, okay, green it will be easy, correct. In the green, first you start from city 0, again you stay in the city 0, again you can stay in the city 0. Now you can check again, if we from this path city 1 then city 0, then actually we are trying to stay here, then again we are actually calculating this path again, whatever the path actually I have, again we are actually calculating what is the score actually I can maximum earn from here, maximum score I can get. So again we are calculating, then we are returning. So if we store this path in somewhere, that is written that in the day 1 if I come to this city 0, what is the maximum score actually I can get, if I store this will actually optimize this, like only one times actually we will calculate this, and next time whenever we come here, then okay, this is already I've calculated day 0, if I come to this city 0 day 1, then what is the maximum score actually, and if it will be also optimize this. So that's why what have I taken, I have taken a 2D variable, 2D vector tb n cross k. N means on which city, and k means on which day actually we have I'm here. So that's why I will check in the dp vector if our city value on this current city on the current day am I already calculated this value. If I have already calculated this, if not equal to -1, that means what, I have already calculated this return from currently here, right? You got it. And if it is not first time we are coming, so that time we have to calculate this, and we are storing this. How is it storing? We are actually assigning this value in the index dp city current city, and the current day we are coming this current city. So I'll store this and return from here. Got it? How to optimize this? So this is actually recursion plus memoization, correct? Thank you. If you like the explanation, please like the video. If you not subscribe, please subscribe the channel, okay.